Okay, so I wanted to go over a quick couple of examples when it comes to motion or distance over time graphs and what they tell us. Some of you are having some issues interpreting some of the graphs on this week's assignment, so this is a quick down and dirty demonstration here. So I only have two examples for you. And the first example goes for being able to calculate a rate of speed when you're just simply looking at a graph. So what you see here on this graph, you've got your distance or your position in meters, and on the bottom of the graph you have time in seconds. So after the first second has passed, you have traveled 10 meters, or 10 meters per second. After the second second, you have traveled 20 meters. And if you divide 20 by 2, you get 10 meters per second. And again, if you look at the third second, you go 30 meters, and you did that in 3 seconds. You do the division, 30 divided by 3, that gives you 10 again, so it's 30 meters per second. So you can see whatever the object is moving on this graph, it is moving at a steady 10 meters per second rate. So that's its rate of speed. You can do this if these numbers were 2 instead of 10. I'm sorry, if this was 10 and this was 2, so it was every 2 seconds, well, then it would be 10 divided by 2, and that would be 5 meters per second. So you're simply dividing this number here by this number here, and that's how you get your rate. Now, this is also how you calculate the slope, but we don't need to get into that. So then the other thing is looking at what these things are telling you. So here is a bunch of different lines on this particular plot, and let me kind of go into what these are showing. So the steeper the slope, or the steeper this line is, the faster it's going. And how do I know that? Well, each one of these tick marks here is 1 second, and this is your distance in meters. And if I go up here, here is 10 meters. And if I go over to I'll go 20 meters here, and then I'll go over here. So then I go down to the bottom, and that's 1 second. So in 1 second, I went 20 meters. So that's 20 meters per second. Now, if I look at this blue line here, I get all the way at 1 second. I don't even quite get to 10 meters. So this is like maybe 7.5 meters per second. So clearly, the steeper the line, the faster the object is moving. And that makes sense because this one is going a further distance in a shorter amount of time. So another way to look at these, so it's not just about how fast you're moving, but it's whether or not you're moving at all. So on this blue line here, you can see it gets up to 5 seconds here, and it stops at 40 meters. And as time progresses, it stays at 40 meters, meaning it hasn't gone further away. So when you see a flat line here on a distance and time graph, that means your object has stopped moving. So it's staying at 40 meters. Now, if it suddenly starts decreasing, well, now you're losing distance. So that means the thing is coming back to you. So it's going back to its original place. So this blue line here is like you went to the store, now you're at the store doing your shopping, and now you're returning home, and you're returning home at a faster rate, because notice this is a steeper slope than this is here, okay? And then this red line here shows you what it looks like if you're accelerating. Accelerating means you're getting faster as time progresses. And you know that on a distance time graph anytime it's curved. So if I'm moving at a steady rate, it's a nice straight line. So I'm going the same speed the whole time. But if I'm accelerating, I'm going faster and faster and faster as time goes on, then you're going to see a curve upwards. Or if I'm slowing down, you're going to see a curve downwards. Okay, so you kind of see the, basically it's this shape would be you're slowing down, and this shape would be you're speeding up. So this gives you a quick breakdown in just a few minutes on what all of these things mean. Hopefully this will help you get through the rest of your reading assignment this week. All right, see you later.